Mathematics Part 2, Standard 10, Chapter number 3, Circle. Problem set 3 and example number 14. In the figure, O is the center of the circle, chord PQ congruent chord RS, angle POR is equal to 70 degree, arc RS is 80 degree. Find first arc PR, arc QS, arc QSR, QSR. Chord PQ congruent chord RS. This is given. So measure of arc PQ congruent measure of arc RS. Congruent arc of the congruent chords are congruent, but RS given 80 degree, so PQ is also 80 degree. First question, measure angle POR equal to measure arc PR. Central angle property, minor arc and central angle are equal, so POR is equal to gives 70 degree. So measure of arc PR is 70 degree. This is given, so measure arc is 70 degree. Second question, measure of arc QS plus measure of arc PQ plus measure of arc PR plus measure of arc RS. Total becomes circle, so 360 degree measure of circle. So measure of arc QS plus PQ is 80 degree, PR is 70 degree, RS is 80 degree, total 360. Measure of arc QS is equal to 360 minus 230. So measure of arc QS equal to 130 degree. So measure of arc QSR is equal to measure of arc QS plus measure of arc SR. Sum of arcs. QS is 130 degree, SR is 80 degree. So 130 plus 80 is 210 degree is measure of arc QSR. In this way we solve example number 14. Example number 17. Chord EF parallel chord GH. These are parallel chord. Prove that EG, chord EG, congruent chord FH. Fill in the blanks and complete this activity. Draw segment GF. Angle EFG, congruent angle FGH. These angles are alternate angles. Alternate angles. Equation number 1. Angle EFG is inscribe angle 1/2 measure of arc EG. Inscribe angle theorem. Angle FGH is also inscribe angle 1/2 measure of arc FH. Inscribe angle theorem. Measure of arc EG and FH, inscribe angle theorem. From equation 1, 2 and 3 both are congruent, so arcs are congruent. So measure of arc EG equal to 1/2 cancel. So measure of arc FH. So both arcs are congruent. So chord EG congruent chord FH, congruent chord of congruent arcs, congruent chords of congruent arcs. In this way we solve the question number 17. Question number 19. In the figure, circle with centers C and D touches internally at point E. D lies on the inner circle. D lies on the inner circle. D point is on the inner circle of. So chord EB of the outer circle intersect inner circle at point A. Prove that sec EA congruent sec AB. Draw sec AD and ED. ED and AD draw. So sec ED is the diameter of inner circle or small circle. So angle EAD is 90 degree. Inscribe angle in semicircle because diameter becomes angle on the circle is 90 degree. Inscribe angle in semicircle. DA perpendicular chord EB. EB is a chord of outer circle or big circle. So by theorem of perpendicular chord drawn on chord bisect the chord EA equal to AB. So sec EA congruent sec AB. In this way prove this 9th example. Example number 20. In the figure, AB is the diameter of circle with center O. The bisector of angle ACB intersects circle at point D. Prove that AD congruent BD. Complete the following proof by filling the blanks. Draw segment OD. Draw sec OD. So angle ACB is equal to 90 degree. Because AB is diameter, inscribe angle in semicircle is 90 degree. So angle DCB is 45 degree. Why 45? Because CD is the angle bisector. This is the angle bisector. This is 90. 90 is a half. So CD is the bisector of angle ACB or C. So arc DB congruent arc AD. Inscribe angle theorem. Because this is inscribe angle 1/2 AD. This is inscribe angle 1/2 BD. But both are congruent. So arcs are also congruent. So inscribe angle theorem. Angle DOB is a central angle by definition of measure of arc. So measure of arc DB. So DB is by definition of measure of an arc. So OA congruent OB. This is a OA congruent OB. This is a radius. So line OD is perpendicular to seg AB from equation 1 because both are congruent. So when midpoint of chord and center of the circle joins this perpendicular. So seg AD congruent sec BD because this is a perpendicular bisector. So point D is equidistant from A and B. So AD equal to sec BD. In this way we prove the example. Question number 21. In the figure, MN is a chord of circle with center O. MN is 25. L is a point on the chord MN such that ML equal to 9 and OL equal to 5. Find the radius of the circle. Some constructions here. Draw seg OP perpendicular chord MN. Joint ON. By perpendicular chord theorem, PM equal to PN equal to 1/2 MN. Perpendicular drawn on chord bisect the chord. So 1/2 here is 25. 25 is a half. PM equal to PN equal to 12.5. So LP equal to MP minus ML. LP is 12.5 minus ML is 9, so 3.5. LP is 3.5. In triangle ALPO, angle LPO equal to 90 degree by Pythagoras theorem. OL square equal to LP square plus OP square. OL is 5 square, LP is 3.5 square, OP square. 5 square is 25, 3.5 square is 12.25. So OP square here minus, so OP square equal to 25 minus 12.25 is 12.75. Equation number 1. OP equal to root 12.75. In triangle OPN, OPN is equal to 90 degree. By Pythagoras theorem, ON square equal to OP square plus PN square. ON square equal to OP square plus PN square. OP square is 12.75 from equation 1. And Pn is equal to 12.5 bracket square. So 12.575 plus 12.5 square is 156.25. So here we give sum is 169. So taking square root, ON is equal to 13. 169 square root is 13. So radius of circle is 13 centimeter. Question number 23. In the figure, two circles intersect at point M and N respectively. Secant drawn through point M and N intersect circle at point R and S and P and Q respectively. Prove that RP SQ parallel to RP or RP parallel to SQ. Draw seg MN quadrilateral MNPR and MNQS are cyclic quadrilateral. Angle MRP plus angle MNP is equal to 180 degree. Equation number 1. Theorem of cyclic quadrilateral. Opposite angles are supplementary. Angle MNP is exterior angle of quadrilateral MNQS. By exterior angle of cyclic quadrilateral theorem, angle MNP equal to angle MSQ. Exterior angle is congruent to its remote interior angle. So from equation 1 and 2, angle MRP plus angle MNP means MSQ equal to 180. Both angles are 180, so both are interior angle. So sec SQ parallel sec RP interior angle test.